Hello kids, welcome to another video. This one is going to be chapter 14 math. And we're going to take a look at that. And so you pull up chapter 14 math and you begin. And this all has to do with work and simple machines, and the formula that we're going to use for the simple machines is pretty similar to all the other formulas that we ever use. And in this one, it starts out the IMA. The IMA formula, if we look at it, is input distance. I wonder why I can't see that. Huh. There we go. Is I M A, and we did this, equals input distance divided by what? Output distance, right? I guess it would be ID over OD. So in this particular case, if the output distance of the machine is 31.3, what is the input distance? Now you'll notice that I don't have any units here. And the reason for that is because it doesn't matter. When we're looking at input distances. The IMA of a simple machine is 15.2, right? If the output distance of the machine is 31.3, what must be the input distance? Well, if we're looking back at this, if our output distance is 31.3, and our IMA is 15.2, then we've got something here, and if this equaled, and we had to solve for 10, what would we have to do with the 2 and 5 to get 10? You'd have to multiply them, right? Same thing. And you can say that they cancel, and you can cancel them, and whatever you do over here, you have to do over here. And that's all good, but it comes down to the same mechanics. So the first one, you simply multiply. Now that's what I'm really trying to get, is there's only a few things you can do in these questions, and that's going to be multiply or divide. So in this particular case, it's 15.2 times 31.3 equals, edit, copy, paste. And you'll notice no units here, right? Don't put units. Calculating the ideal mechanical advantage. A student is working in a grocery store after the school pushes the grocery carts up along a ramp that is 2.6 meters and rises 0.6 meters. What is the ideal mechanical advantage? If we're looking at the ideal mechanical advantage, input distance over output distance, you simply divide, right? So in this particular case, you've got 2.6 divided by 0.6, whatever that is. Edit, copy. Notice there's no units. Many of you take it to the second decimal. A constructor moves a crowbar through a distance of 7.6 meters to lift a load 1.4 meters. What is the IMA? This one, you simply divide. First number divided by second number. All right, and this is, you just designed a machine that uses 7.5 joules of work from a motor for every, this is useful work input. we have to look at what is the efficiency formula for um, this. And so, what is the formula for efficiency? Does anybody know that? Look it up real quick. It should be on page something. And you can look it up anywhere. If efficiency of a machine, and it should give you the images. Oh, you're good. Um, where's that? Here you go. Efficiency is workout divided by work in. In this particular case, this is your in, that is your workout. Hey, right on. Right on, man. Workout times 100% divided by work in. And this one's kind of this question is wrong because this can never actually exceed this. So for this one, it don't matter. Um, yeah, it can. Okay, what is the efficiency? So workout times 100 divided by work in. Um, this is wrong. This is input. This is output. This question's we have to reword this question because a machine that uses 77.75 joules of work, that's its input, and this is your output. That makes sense. So it's just this divided by this times 100. That's where I was going a little bit wrong. This is your input here. So you got 28.7 divided by 77.5 equals times 100. Does that make sense? And then a machine has an efficiency. What do you, and you do 92.2 joules of work on the machine, what will be the work output? So here you have work output. So this is going to be a multiplication problem because on here, the formula is efficiency equals work output over work input times 100. So, and this is asking what will the work output be? Work output, it's the same in the other question. You just multiply work input times efficiency equals work output. And so on here, so here you just 37.4 times 92, right? Divided by 100. So on this one, it's going to have to be divided by 100 because you're going to have to be divided by 100. And so that's just that. Okay. And so once you have all these machines, all right. And this is just the same thing. It's just going to be work input over work output. And this one we do have a power, and we're going to come up with that.